She was trained as an industrial organization psychologist.
They're gonna keep a collaboration.
As leader,
All right, good afternoon.
social
Did
influence
you meet in the
processes.
same,
Very excited about our presenter today. So I want to first start off by saying thank you everyone for joining us. And we're very delighted and thrilled to have Dr. Jose Luchsinger as our 2023 JHAD-RCMAR visiting scholar. Before I get started, I want to do a couple of housekeeping things. First of all, I'd like to say thank you to Ms. Veronica Washington for leading and spearheading, organizing this event. What you see is a product of our hard work. Thank you so much. The other thing I'd like to say thank you to is thank you for Dr. Marilyn Albert for for co-sponsoring this event for us with the ADRC. We're certainly happy to have your collaboration and we enjoy your collaboration over the years. Thank you so much. So now I want to introduce, without further ado, I want to introduce Dr. Luchsinger to us. Dr. Luchsinger received his medical degree from University of Central Venezuela's in Caracas. He'll let me know if I got that right. Caracas. So I'm from Macon, Georgia, changes of Georgia, so the He completed an internal medicine residency program, including 1 year as chief medical student at St. Luke's Hospital in New York City. He also completed a general medicine fellowship at Columbia University Irving Medical Center and obtained an MPH in epidemiology from the Mailman School of Public Health at Columbia University Irving Medical Center. He's been a faculty member since 1999. His research has focused on the relation of vascular, metabolic, and dietary on aging outcomes, primarily cognition in diverse populations. He's conducted a number of studies, cohort studies, and clinical trials, and we're excited that he's going to present to us today on research on risk factors and prevention of ADRD in Northern Manhattan. Without further ado, please join me in welcoming Dr. Jose Luchsinger.
Thank you. So it's a real honor to be here. Thank you so much for inviting me. And it's been a wonderful 2 days. So it's a Friday afternoon, right after lunch. So I hope that my talk is light, and I will strive to keep it as light as possible. So it's not. I just need to point. Okay. Got it.
Yeah. I think you have the.
All right.
Sorry about that.
So just some disclosures. I receive royalties from Springer, etc. The book Diabetes in the Brain. Actually, I submitted my grants, my taxes on Sunday, and my royalties for 2022 were $19 for this book. I do receive a stipend from Wall Street Bluer as editor-in-chief of a journal, and I was a consultant to Merck in 2022, but I'm not doing consulting work for them any longer. Lastly, I want to acknowledge, collaborators across many studies. I don't have time to acknowledge all of them, but a lot of the data that I'll be showing you was done in collaboration with various groups. And lastly, I want to acknowledge my generous funding from the National Institute on Aging, which have helped me during all of my career. So the organization of my talk is the following. First, I want to give a little bit of background, particularly focused on diabetes and related disorders, which has been the main focus of my career, although I've done work in dietary factors, hypertension, and other things. I'll go into observational studies, then talk about mechanisms, and then translation of the findings, including clinical trials. And then I would like to speak about other dementia research that I have also conducted and that I think would be of interest to this JHAD-RCMAR crowd in particular. So first, some background. The following figure depicts what I think most people would agree is the natural history that leads to type 2 diabetes. So the main risk factor that leads to this is to diabetes, the proximal factor is obesity or high adiposity, which leads to insulin resistance and high insulin levels, and eventually leads to glucose elevations, which we call prediabetes below a certain threshold, and then type 2 diabetes when it reaches a threshold that needs treatment. And of course, it's important to recognize that these disorders are accompanied with what's called the metabolic syndrome, which is the collection of hypertension, high inflammation, and dyslipidemia. Now, for the sake of simplicity and parsimony, I will focus mostly on just diabetes itself, because I just wouldn't have time to go over insulin resistance, hypertension, or even the adiposity story, which is quite complicated. But I think as I'm giving this talk, I think everybody has to bear in mind that this is a complex story and that there's a lot of factors associated with glycemia and diabetes. Now, I just put up this slide simply because I didn't know if there were people in the room that are not experts in Alzheimer's disease and dementia. This graphic depicts what could be the natural history leading to dementia. So first, we have normal cognition, and as there's a decline in cognitive abilities when they're still not accompanied by functional impairment, but are accompanied by subjective symptoms and objective findings, we call it mild cognitive impairment. And with increasing deterioration, once there's functional impairment, we call it dementia. And, you know, I'll be talking about these concepts throughout my talk, so I wanted to present them briefly. So let's talk first about observational studies. So this is a table that depicts the hazard ratios relating diabetes to dementia risk in northern Manhattan. And what you can see here, by the way, I'm not sure if, the pointer does work, okay. So this 1.7 means that people with diabetes by self-report or by use of medications for diabetes, that they have a 70% increased risk of Alzheimer's dementia. Now, this Alzheimer's dementia was defined clinically at the time. It was not defined by biomarkers. There was no brain imaging. Now, the association is much stronger for vascular dementia. There's about a tripling of the risk. And then if we take into account all forms of dementia, there's about a doubling of the association. Now, again, these were clinical syndromes. We did not have biomarkers at the time. And so the assumption that Alzheimer's was the cause of dementia was based on clinical features alone. Now, these results are adjusted for vascular risk factors, for history of stroke. So they're supposedly independent and not mediated by vascular risk factors. But you can see how there's a possibility that there could be misclassification between vascular dementia and Alzheimer's dementia, given that the association with vascular dementia is so strong. And this is not surprising because diabetes is a very strong vascular risk factor and a risk factor for stroke. So I think a lot of the research that I've conducted and that I will be showing you later has focused on the question of whether diabetes causes Alzheimer's disease or not, or whether it's all vascular or there's another mechanism of neurodegeneration. Now, this is a single study, but I think it is representative of the larger literature that has been published about this issue in many countries. That is, that diabetes is a strong risk factor for dementia, but the association is much stronger for vascular dementia than for Alzheimer's dementia. And actually, some studies have found no association with Alzheimer's dementia. Now, I'll try to pepper my talk with references to funding and career stages, et cetera. When I did this analysis, I had a K grant, and my mentor was Richard Mayhew, who's listed in the bottom. And then eventually I actually became a project leader after my K award in Richard Mayhew's center grant. And so, for the RCMAR scholars in the audience, I mean, I think that's really a great opportunity to make the jump from the K award to an R01 like mechanism, but not necessarily an R01. And I certainly took advantage of that. Now, the other thing that we've observed in regards to this association is that type 2 diabetes may be an important cause of ethnic disparities and cognitive impairment. As you may know, the prevalence of diabetes is almost twice as high in ethnic minorities, particularly Hispanics and African Americans, compared to white persons. And it is reported as well and widely known that the risk of dementia is also twice as high in African Americans and about 50% higher in Hispanics, or at least that's what gets reported in the Alzheimer's Association facts and figures. And so we looked at whether the disparities in type 2 diabetes explain the ethnic disparities in cognitive impairment. And cognitive impairment in this case included MCI and dementia bundled together. And what you see highlighted here is the population the risk of cognitive impairment attributable to diabetes. So you can see that it's over 6% in non-Hispanic whites, but it's almost 15% in non-Hispanic Blacks and about 14% in Caribbean Hispanics. So it's almost 3 times the risk of dementia attributable to diabetes in ethnic minorities is almost 3 times that of non-Hispanic whites. And we did an analysis, actually Jamie Noble, who's now the director of the clinical core at the Columbia ADRC. He actually did some very fancy hypothesis testing and other procedures. And what we found was that if you reduce the ethnic disparities in diabetes, you could close the cognitive impairment gap by about 17%. Of course, this assumes that the cognitive impairment is caused by diabetes, which we haven't proven completely, but I think most people agree that this is the case. And at the time that I did this association, again, I was an investigator in Richard Mayhew's P01, which is referenced at the bottom right, but I had also become by accident the PI of the NIMHD Center of Excellence at Columbia after the main PI left for the University of Miami. So anyhow, that was an accidental way of becoming a center director, which I also had the opportunity to do. Now, so a lot of the research that I've done has been, again, in trying to examine the mechanisms for the associations that I just reported. And what this means really at the end of the day, which I mentioned before, is whether diabetes causes Alzheimer's disease. And Alzheimer's disease, as most of you know, is the neuropathological hallmarks are plaques made of amyloid and tangles comprised of tau. And of course, the only way many years ago to be able to ascertain an association of diabetes or any other risk factor with neuropathology was to wait for autopsy. And there's a handful of studies that have looked at this question. So this is from a Japanese study, the Hisayama study, which was published in Neurology more than 10 years ago, and it shows the odds ratios of 2-hour plasma glucose, fasting insulin, and a measure of insulin resistance, the home IR, which is basically computed with fasting insulin and plasma glucose, which was measured actually 10 years before autopsy. So actually, in that sense, it's one of the most elegant studies that I've seen looking at this question. And they found that the odds ratio of having amyloid, that is Alzheimer's pathology in the brain, increased in a dose response fashion with higher levels of glucose, higher levels of insulin, and higher levels of HOMA-IR. So this is a very nice finding because it's consistent with the idea that diabetes causes Alzheimer's disease. But the problem is that this is only one of two studies that have actually reported this. The other study happened to be in Japanese Americans in Honolulu, so I don't know if there's an ethnic or racial issue there, but the majority of studies, about 5 or 6 others, including one from Rush, who are a university in Chicago, who have been incredible in doing neuropathologic studies, have shown actually that diabetes is not related to plaques and tangles in the brain. Now, a problem with these studies is that there's selection bias, because until recently, only a minority of people agreed to get brain autopsies. Increasingly, studies, I think pioneered by the group at Rush, now require brain donation for entry into the studies, which creates a different type of bias, but at least they have more complete ascertainment of brain pathology. Now, the field has been revolutionized by imaging and other biomarkers. First, CSF biomarkers more than 10 years ago, and in the last 10 years, imaging biomarkers. And so now we have MRI, where we can look at brain volumes and cortical thickness in general, but also specifically in areas affected by Alzheimer's disease, in order to measure neurodegeneration. So we have amyloid PET. In this case, what you're seeing is the typical accumulation of amyloid in the frontal lobes in red. And so now we can look at the pathology in vivo. We also have more recently, but increasingly available, tau PET, where you can actually see the distribution of the tau ligand in the temporal lobes and spreading posteriorly. And of course, with MRI, you can also look at cerebrovascular disease. In this case, we're seeing white matter hyperintensities and that are periventricular, which is one of the most studied measures of cerebrovascular disease. So, thanks to this, we don't have to wait for autopsy anymore, and this has facilitated research into mechanisms of Alzheimer's disease. And, the availability of biomarkers has led to the National Institute on Aging Alzheimer's Association research framework, which basically uses a biologic definition of Alzheimer's disease that is based on biomarkers independent of cognitive measures. And in this framework, the main distinction that is made is between people who are amyloid positive and amyloid negative. People who are amyloid positive are considered to be in the Alzheimer's continuum. People who are amyloid negative are considered to have non-AD pathologic change. And then there's other classifications that you can make based on whether people are tau positive or neurodegeneration positive. And the main assumption in the amyloid hypothesis that amyloid accumulation leads to acceleration of tau accumulation, which leads to neurodegeneration, which leads to cognitive impairment, which we see here in panel A. But there's all sorts of different combinations, even of factors that we just don't know right now. For example, there's other pathologies such as TDP-43, alpha-synuclein, which we don't have biomarkers for, but which will probably be folded into this framework. Now, I was speaking to some of the scientists yesterday, and I was telling them that if you want to do Alzheimer's research, I think it's a good idea to use this framework, because you don't have to reinvent the wheel. You can refer to a framework that others have come up with. And I think it simplifies things as well, because particularly if you do the first distinction of amyloid positive or amyloid negative, which you can now do with biomarkers, it just facilitates how you pose questions. Now, this is very controversial because the framework that is, because not everybody who has these biomarkers develops cognitive impairment, not everybody who has cognitive impairment has these biomarkers, but the recent clinical trials, efficacious clinical trials of anti-amyloid agents in early Alzheimer's disease, which have demonstrated that clearing amyloid from the brain actually results in modest but significant improvements or slowing of decline in cognition and in function, actually I think is now giving more support to the NIA research framework than before. And it was under review during the summer, but I don't know if the revision of the framework has been published yet. I know it was up for review, and it's available. You can Google it and you can find the revised framework. So anyhow, so some of the research that I've done to answer the questions about diabetes actually uses this framework. And in this case, we did a amyloid PET scans in 350 Caribbean Hispanics from New York City who were on average 64 years of age. And what we found, surprisingly, here we classified amyloid status as low, intermediate, or high. High is what most people would call amyloid positivity, which is above a certain threshold. And actually what we found was that actually people with diabetes had the lowest prevalence of amyloid positivity, even lower than people who had pre-diabetes or undiagnosed diabetes. So one of the things that we did was ask whether it is possible that diabetes medications could explain this, which in this cohort, which is fairly young, the majority of the diabetes medications was metformin, which is not surprising because it's the first line of treatment for type 2 diabetes. And metformin was related to a decreased odds of amyloid positivity. Now, this is cross-sectional data, so it's hypothesis generating at best, but it's at least suggestive that diabetes medications could be related to lower amyloid in the brain, and then could explain some of the neuropathologic study findings that I had explained before. Now, there's at least another study in the Alzheimer's Disease Neuroimaging Initiative that has reported similar results in cerebrospinal fluid. Now, we looked at whether we could replicate this finding in African Americans from New York City and non-Hispanic whites with a similar age range. They're age between 60 and 69 years of age and are on average 64 years old. And actually, this association between diabetes status and markers of neuropathology, including the amyloid, which I showed you, but also a cortical thickness. People with diabetes have lower cortical thickness, have higher white matter hyperintensities, not surprising because it's the vascular marker, and have lower performance in the selective reminding test, which is a memory test, was present only in Hispanics, but not in African American white participants. Now, the sample for African Americans and whites was smaller, but nonetheless, the effect estimates do not suggest that this is a lack of power issue. So actually my grant my grant renewal to continue follow-up of the African American participants and white participants was reviewed yesterday, and I hope that it gets renewed. And one of the things that I asked was to increase the sample size to make sure that the problem is not that we're lacking power. Now, I'm a clinician, I'm a general internist, and I seek to translate into the bedside or the office, if you will, the findings from the studies that I've done. So in this case, the main theme is the relationship between diabetes and cognitive impairment and Alzheimer's disease in particular. And so the translation implication is whether prevention of diabetes or treatments for diabetes can result in better cognitive outcomes. And so this slide shows results of a landmark study, which was called the Finnish Diabetes Prevention Study, which was a study of people at high risk of diabetes, which received an intervention of diet and exercise, which led to weight loss mainly, versus a control intervention. And this was the first study to show that you could prevent diabetes through lifestyle intervention. And you can see here that people in the control group, even 8 years after randomization, had a faster time to developing diabetes than people in the intervention group. So I received funding from the American Diabetes Association to do cognitive testing approximately 10 to 12 years after randomization. And actually, I had the pleasure of going to Finland several times to carry out the study with colleagues there. And basically, we found no difference in cognitive testing, including the CERAD battery and the trail making test between the intervention and the control group. And again, this was funded by the American Diabetes Association by an R01 type mechanism, but from a foundation, not from NIH. And it's important to remember that these people were all high risk. There were no normals there. Now, another study that I've carried out related to diabetes treatment is testing whether metformin, which I said before, we hypothesized that it could clear amyloid in the brain, can prevent cognitive decline in people at high risk, in this case, people with amnestic mild cognitive impairment. And we carried out a pilot clinical trial of 80 participants with amnestic MCI, 40 with MRI and FDG PET. At that time, we didn't really have amyloid PET available, or it was just getting started, or it was being experimented on. And so with the FDG PET was what gave us evidence of neurodegeneration. And we randomized people to metformin 2,000 milligrams a day versus placebo for 12 months. And we randomized participants by 8.4 studies. And this was funded by an R01 from NIA, but also supplemented by funding from the Alzheimer's Disease Drug Discovery Foundation. And what we found was that after 12 months, the metformin group here in light blue actually had better changes, or that is improvements in total recall of the selective reminding test, that is better memory performance, than people in the placebo group. Our co-primary outcome, which was the ADAS-Cog, did not show that result. But we were encouraged by this because, I mean, I don't know what Dr. Albert thinks about this, but at least, you know, the reputation of the ADAS-Cog is that it's not as sensitive to changes in early stages of cognitive impairment as something like the selective reminding test. So, you know, furthermore, I had the privilege with Herman Moreno, who was a basic scientist at SUNY Downstate in New York, to test metformin in diabetes mouse model. And what you see here is the difference in number of shocks that a mouse receives in order to remember a task between those that are treated with metformin in blue and those who are not treated with metformin. And you can see that the group that was not treated received many more shocks than those that were treated, which means that they had worse memory than those that were treated. And actually, those treated with metformin behaved very similarly from a memory standpoint to the heterozygous mice, that is the wild type mice, those without the diabetes. So this has given further support to our belief that metformin could be beneficial for the prevention of Alzheimer's disease. And so right now we are conducting a clinical trial of metformin in persons with amnestic MCI between the ages of 55 and 80 years old, much longer than the other clinical trial. And we are looking at changes in the free acute selective reminding test, which is similar to the selective reminding test that I showed you before, but are more advanced. Changes in a composite measure of cognition, but also changes in the biomarkers following the NIA research framework, as I said before, including changes in plasma biomarkers of Alzheimer's disease, which are the rage right now. This is funded by a Neuro1 from NIH. By the way, the coordinating center, as Dr. Albert knows, is here at Hopkins. Dan Hanley at the BIOS group and the China Innovation Center, funded by NCATS, is the coordinating center. And unfortunately, we were beginning the trial or about to begin the trial when COVID hit. So we're running 2 years, more than 2 years late, but we're scrambling to catch up and try to finish the trial. So the other study that I've been involved in is the Diabetes Prevention Program Outcome Study, which was a clinical trial of metformin versus placebo versus lifestyle in people at high risk for Alzheimer's disease. And we were funded last year to do a study of Alzheimer's disease and Alzheimer's disease related dementias. And so these were the long-term results of this study, in which the red is the metformin group, the purple is the lifestyle group, and the dashed lines in blue are the group originally randomized to placebo. And you can see that even after 10 years, the metformin and the lifestyle arms did much better in terms of hemoglobin A1C, that is a measure of glycemia, than the other groups. So what we're doing now is that we're adding the NAC-UDS, which is what's used by the ADRCs to adjudicate cognitive syndromes. We're also doing brain MRI in about a third of the sample of 1,900 people. And we're doing also ascertainment of cerebrovascular disease, and we're doing the amyloid PET as well. And again, what we're trying to determine here is whether metformin is related to lower levels of amyloid, and in general, try to characterize the nature of the neuropathology underlying cognitive impairment in people with diabetes and pre-diabetes. So in conclusion of this part of the talk, diabetes and pre-diabetes are associated with cognitive impairment, including Alzheimer's disease and Alzheimer's disease-related dementias, and account at least partially for ethnic disparities in these conditions. The diabetes seems to affect cognition through multiple mechanisms, including vascular, neurodegeneration. The amyloid is a big question mark because of the confound of treatment, and metformin is a candidate drug for repurposing for dementia prevention. Now, I wanted to, because this is the Resource Center for Minority Aging Research, I also wanted to, in following actually my meetings with some of the scientists and knowing of their interest, I added some slides that deviate a little bit from the title of my talk, but I thought would be of interest. So I've also done work with dementia caregivers. And before you say, well, you're crazy, how is it that you're jumping from one thing to the next? Very quickly, the way this developed was that I wanted to do a prevention program in the outpatient setting for dementia risk factors that included the whole family, including the caregivers. Anyhow, and I ended up breaking it into little pieces. And so I had to sort of develop the caregiver part before I could bring it all together. And so we conducted a project called the Northern Manhattan Caregiver Intervention Project, which was a randomized control trial of the NYU caregiver intervention, which is very well known for those in the field, versus regular case management. So case management was conducted by a Alianza Dominicana, which was a community-based organization in Northern Manhattan. This is myself in a younger stage of my life with the rest of the team. And but anyhow, one of the conversations that I had with a scholar yesterday was that about engagement with the community in order to help you conduct research. And in this case, I mean, they were our subcontractees. I mean, we were paying them to actually do the case management. And this was the first time that the NYU caregiver intervention was tested in non-white people. In addition, one of the things that we found was that the great majority of caregivers were children caregivers, and particularly women. So it was daughters, which probably is not a surprise to any of you, but actually the great majority of the literature until that point on caregiving was mostly in spouse caregivers. And one of the things that we found was that, you know, spouse caregivers and children caregivers are just completely different. And then the other characteristic of this sample is that the great majority, over 50%, had a very low income. And so we found at baseline that the correlates of caregiver burden or distress related to caregiving and depressive symptoms, where actually the health of the caregiver, the self-reported health of the caregiver, measured by the Charlson Comorbidity Index, and also in addition to, of course, the severity of the person with dementia. And the other one was actually the reported social support networks of the caregiver. But when we did the clinical trial, after 6 months of follow-up, and even after 2 years of follow-up, the intervention only lasted 6 months, we found that there was no difference between the NYU caregiver intervention and the control case management intervention. By the way, both groups got case management. All of the groups got case management. And but you can see actually that there was improvement in the SARIT caregiver intervention and some improvement in the geriatric depression scale as well in both groups, which may suggest that any type of support for caregivers is helpful. Furthermore, we conducted the first trial comparing the REACH and the NYU caregiver intervention head-to-head. We did it in Hispanic caregivers, but this was the first time, and maybe it's been the only time, that there's been a head-to-head comparison of these two interventions in any population, and we found no difference between the groups in the SARIT caregiving burden scale or the geriatric depression scale. Now, one of the insights that we received from the caregivers is that the main symptom is anxiety, but we didn't mention, you know, we measured anxiety indirectly with the SARIT depression, with the depression scale and with the SARIT caregiver burden, but there are dedicated anxiety scales, and we didn't do it. So we applied to continue this program through a U grant subsequently, but we didn't get funded. Long story short, and we're not doing it anymore. But the other thing that I wanted to point out, again, I had a conversation yesterday about how to engage the community in this type of research in particular. And here, for example, Ilana Donner, she's the executive director of a dementia-focused daycare center. And Jed Levine was the executive director of what used to be the Alzheimer's Association New York City chapter, now called Caring Kind. And they were also subcontractors. We were paying them and we were paying their personnel to help us in the clinical trial. By the way, this is the only study that I finished on time. And actually, I think it maybe, this was funded by PCORI, and the PCORI people told me that it was the only PCORI study, clinical trial, that was finished on time. And it was thanks to the help from the community partners. So I mean, what you need to do is just really make them partners in the research and pay them, and use their personnel for recruitment purposes, etc. Now, lastly, I told you that an important correlator of caregiver health was self-reported health. So we tried to get data on biomarkers or objective biomarkers of health rather than self-reported health. So we got hair cortisol, hair DHEA, we got measures of allostatic load. And anyhow, this is a complicated model, a structural equation model from Jean Teresi, who I work with at Columbia. Long story short, what this shows actually is that contrary to what we were thinking, stress was related to higher levels of DHEA, which is the opposite direction where this should go. So we're scratching our heads about this. And there is a literature out there, or at least there's anecdotal reports of the positive consequences of caregiving and positive caregiving. And all I can say is anecdotally, I've spoken to caregivers who tell me, it's not stressful. My parents gave to me when I was a kid, now I'm giving back to them. And so this is a very complicated matter. Now, the other side of dementia research that I wanted to show you and that I'm currently conducted very actively is sex and ethnic racial differences. And again, applying the National Institute on Aging, Alzheimer's Association research framework. And this table shows the comparison of means in different biomarkers and markers of cognition as well between sex groups, and this is adjusted for age and ApoE4. And among Black participants and Hispanic participants, females have higher amyloid in the brain and higher tau in certain regions compared to males. And this is despite females having larger cortices, that is less neurodegeneration, and performing better in tests of memory, which, by the way, is not surprising at all. I mean, I think that's what you widely see. So we're following this up in both the Hispanic cohort, which that grant was renewed. And again, I'm hoping that I got a favorable review in the renewal of the grant for non-Hispanic participants yesterday. But as you can see, this is not present in white participants. So I consulted with Michelle Milkey, who has done work in this area, and she suggested that we add questionnaires of obstetric history, because maybe a higher incidence of preeclampsia, hypertension, etc., could explain these racial disparities, of course, related to socioeconomic status, health status, etc. And then the other thing that we've looked at is at differences in these biomarkers between ethnic and racial groups, and here's adjusted for age and sex. And all these people are between the ages of 60 or 69, about 64 years on average. So there isn't, there's very little room for confounding by demographics. And what you can see here is that although the p-value is not significant, it seems like, white people have higher burden of amyloid in the brain than Hispanic and Black participants. And actually, when you look at this by amyloid positivity, the prevalence of amyloid positivity in white people is twice as high as in Hispanic participants and Black participants. And here you can see actually that there's a significantly lower tau in the middle temporal cortices and in the middle inferior temporal gyra in African Americans compared to Hispanics and whites. And but at the same time, African Americans have thinner cortices, and in this case the Hispanics and African Americans have higher white matter hyperintensities, again indicative of cerebrovascular disease. Not surprising because of the rates of diabetes, higher rates of diabetes and hypertension in these groups in our study and nationwide. And also, the white persons had a better performance in the selective reminding test, which was partially washed away by education. So before you say that this could be, explained by demographics, etc., you may know that there's a literature showing that ApoE4, which is the strongest genetic risk factor for Alzheimer's disease, is weaker in ethnic minorities. So we looked at this again with these biomarkers, and this is what we found. What we found actually is that ApoE4 is not related at all, zero, with amyloid in the brain and other biomarkers, whereas in Hispanics, it's actually significantly related. Actually, it's the strongest predictor of amyloid in the brain, and it's even stronger in non-Hispanic whites. So there are definitely not just sociodemographic differences or differences in social determinants of health, but also differences in the biology of Alzheimer's disease. And this is not a shock. This has been published, although I think that we're one of the few studies to show it so convincingly in late middle age. And I think this points to the fact that, the newer therapies that I indicated before may be good for certain groups, but not others. And actually, or 90% of the study participants in the clinical trials of lecanemab and donanemab were white. So that is really an issue. So now I wanted to finish my talk because again, I think this talk is geared in great part to the RCMAR scientists here, is to talk about lessons learned during this journey. And this is a slide that I prepared for the Butler-Williams program, which used to be the Summer Institute, which is where I got to know Marilyn Albert in 1999. She doesn't remember, but I do. So anyhow, the first thing is to plan, but be flexible, So we were talking about 2-year plans, 5-year plans yesterday. Definitely a good exercise, but you have to be ready for it to change a little bit. They work most of the time in my experience, but not always as planned. So you should not be rigid about it and be open to unplanned opportunities. Many of the things that I showed you before just sort of fell on my lap, and I took it. I took the opportunity. Be out there. There's no downside to networking. Ask for help and collaboration. We were talking before about the differences between doing Zoom or doing in person. I recommend in person. I mean, it's really incredible how much you learn from just random contact with people. So definitely a good exercise. Be persistent, but change when needed. I think persistence is one of the most important traits in this line of work. But there's been a lot of talk. I've heard a lot the Albert Einstein saying that madness is to try the same thing over and over again and expect a different result. But this has been reported apropos of what's going on with the leadership in Congress right now. But anyhow, so you have to. So it's important to be persistent, but you have to look at yourself in the mirror and know if something that you're doing, maybe it's not the right time and you have to wait for the right time, but maybe you're doing something absolutely wrong. And you have to be able to make that assessment and listen to others if they tell you that. And then don't take anything personally. I think the peer review system is not perfect, but it works. And I'm talking about grants and manuscripts in this case. If you get angry when you read your summary statement or the reviews of a paper, just put it down, wait a week or two, and then come back to it. And you'll find out that actually some of the things that are some of the feedback that you're getting makes sense. Be focused. I think in my talk, and by the way, this is in the realm of do as I say, not as I do. But I think it's important to really narrow down at the beginning of your career, just stick to something narrow, and then you can expand, or otherwise you're going to be in trouble. So if a mentor or collaborator is telling you that you're all over the place, you need to listen, and then keep it simple. We're all trying to tackle very complex issues, but if you don't, another Einstein saying you could make things simple but not simpler, but you have to make them simple just for your own sake, and also because you're trying to sell your concepts and your projects to others in grants and in papers. And if it's too complicated, then no, you're not going to get good reviews. So anyhow, if anybody has any questions, this is my email, and I'm happy to be in touch at any time. Thank you very much.
Thank you so much, Dr. Leslie, for a great presentation. I think we do have time for some questions. I see one question. Dr. Wallace, do you have a question?
Yes. Hello, Dr. Jose, and thank you again for your guidance yesterday at the one-on-one Zoom meeting. I really enjoyed your presentation, but I'm wondering, or maybe just to add to your brilliant presentation, when we talk about the relationship between diabetes and cognition, have you ever extended some of your work to looking at low-income communities and food deserts in the built environment? Because when you were discussing your findings, I was just thinking about how the social environment and access to resources must tie into that. And just briefly, I'll say something about the APOE4 and not related to amyloid in the brain for Blacks, and how that may not be social, environmentally imposed. It may be more biological. I think that's a great opportunity to really think about gene environment interaction, because when you said that, I thought about that's a good example how sometimes we can't really tear apart the interaction between genes and environment, and how over time communities build resilience and buffers against certain hardships, and that also modifies gene expression. So it would be interested to see if you looked at that intergenerationally over time, if you would probably be able to see how maybe the environment and genes kind of interact around that. Thank you so much.
Thanks, Gail. Yeah, so what I can tell you is that I have access to the data to look at these things. So I'm a co-principal investigator in the Alzheimer's study of the multi-ethnic study of atherosclerosis, and there's a neighborhood ancillary. So we will be able to look at those associations. But there's only 365 days in the year and 24 hours in the day and 7 days a week. And I'll let others, I'll have to collaborate with others to look at this question. By the way, I'm very interested in the issue of social determinants of health. When I was in the director of the P60 Center, NIMHC Center of Excellence in Columbia, I actually worked with people at NIMHD to try to come up with a summary index of SDOH burden if you can. I mean, one of the problems that I find is that everybody has their favorite scales for social determinants of health. There's little harmonization, and then different domains are so correlated that it's very difficult to choose what to do, because socioeconomic status is related to education, and it's related to the built environment, etc. So it's difficult to disentangle all these things. And actually, I applied for grants to do this, but I didn't get funded. So again, going back to the keep it simple principle, I really like to do that, although sometimes because of the, grants require that you be more complex. But I guess that's a long way of saying that if I cannot simplify my study and cannot do it in data sets that have the right data, I have not had a chance to look at the built environment and the like. And again, so you have to find a way to disentangle all the other things. Thanks. Yes.
What do you make of the failure of the trials of lowering hemoglobin A1C?
Yeah. So this is actually a theme. This is actually a theme that's come not just for cognition trials, but trials.
Give me a second.
Excuse me, Jim, can you mute? Jim, can you mute yourself, please?
Yeah, but other trials. So one of the things, which is that, interventions that prevent diabetes don't prevent the consequences of diabetes. And I think there's several potential explanations for this. One is that, first of all, the groups in which these interventions were applied, they were high risk groups to begin with. So, that you don't have like people with normal metabolism or people who, so you're beginning with a high risk group to begin with. Another thing is that I think that many of these interventions, once you turn them off, the consequences, that is the benefits, wash away. So if you do lifestyle and things like that, you really need to keep it over time, and you need to measure it when you're on the intervention. The way that I structure the studies that I showed was to look mostly at long-term consequences of the intervention, and I should have said this after the interventions were no longer ongoing. Although with the metformin in the diabetes prevention program, it was different because people stayed on metformin over time. And then the other thing is, there is this concept that's called metabolic memory, which is that, or some others call the legacy effect, which can work in several ways, which is that the metabolic consequences, whatever it is, transcriptome consequences, etc., or of metabolic insults in particular, remain over time and may not revert. Although in some cases, what happens is that it may take decades or many years for the benefits to be seen. So for example, there was a study called the United Kingdom Diabetes Prospective Study, which was a landmark study of diabetes treatment in the UK. And there was a metformin group there. But anyhow, the diabetes treatment group, the more intensive diabetes treatment group, had no effect on mortality within the life of the trial. And then when they did an analysis 10 years after the end of the trial, they actually saw the mortality benefits. So, I haven't tried applying for a 25-year grant, but maybe I'll try. So it's very complex. I personally don't have, this is speculation. I don't have an answer to the question.
Thank you.
You're welcome.
I see a mall and then Maryland.
Hi, great talk.
Thanks.
I think, could you tell us maybe how you think diabetes or elevated glucose or insulin resistance is directly causing, like, what do you hypothesize? How is it directly causing dementia?
Yeah. So let me begin by saying first that although I've published on insulin resistance, etc., I think that glycemia is the main thing. Okay, and I have collaborators who think that it's the insulin, but at least in my research, it seems that glucose is the thing. So I don't have a clear answer to your question, but the issue with glucose and related downstream consequences is that it hits many different pathways. So it hits a vascular pathway, it hits advanced glycation end products. Actually, hemoglobin A1C is a glycation end product on its own. And so one of the things that, for example, we're trying to look at in other studies that I didn't show here is whether the cognitive impairment in diabetes correlates with the typical microvascular outcomes in diabetes, that is neuropathy and for example, kidney disease, because that would suggest at the very least that the same mechanisms that lead to that would have to do mostly with glycation and things of that sort, is causing the same problem. One of the things that we're doing in the diabetes prevention program outcome study is we're going to get neuronal exosomes and peripheral exosomes in everybody. And we're going to look at insulin signaling and other related pathways so we can try to answer this. So sorry, I don't have an answer to your question, but those are the grants that I'm going to write for the next 10 years. So to precisely try to get to that.
Maryland?
Yes.
So you're finding on the lack of a relationship between ApoE4 and amyloid status in African Americans is really fascinating, especially given that they have a higher prevalence of dementia. I know that the group at Columbia has a lot of expertise in genetics, so I was wondering if other genes have been found that are related to amyloid status.
Yeah, so the ABCA7 is, I think some people have talked about as the ApoE4 in African Americans. So actually we're going to do GWAS in the African American, or rather I requested funding in my renewal application that was reviewed yesterday to do GWAS to characterize ABCA7 in particular, but other genes as well. But I think that the evidence for and there's this whole explanation that in African Americans it's a funding, there's a founder's gene effect. Actually, ApoE4 prevalence in African Americans is around 40%, whereas in whites is around 20%. Anyhow, but where I'm going is that the observation is very compelling that there's just a complete lack of association, while in other groups it's just very, very strong. So I collaborated with Christian Wrights and with Joe Lee, who are genetic epidemiologists, and they're helping me tackle this question. So, yes.
George?
Yes, yeah, so thanks so much, Jose. I really enjoyed your talk and such important work. I was wondering, in terms of the diabetes prevention program outcome study, you mentioned the two groups, lifestyle group and the metformin group. And I couldn't tell from your graph, were there any differences in those two groups in terms of statistically? It seemed like at some points they've,
Yeah, so
I was also wondering if you could also comment on any sort of negative, unexpected negative side effects of metformin.
Yeah.
People tolerate the drug over time.
And I apologize because I actually took out a bunch of slides and because otherwise I would have gone over time. So the DPPOS. So in the first 3 years of the study, again, when the actual active interventions were ongoing, the lifestyle intervention was much more effective than metformin, okay? But metformin was still better than placebo. So the lifestyle intervention after 3 years, the prevalence of diabetes was 50% lower than in the placebo group, which, by the way, it's exactly the same reduction in the Finnish study. So very consistent across both studies, actually. The metformin group had about 25 or 30% lower prevalence of diabetes. Now, the DSMB for the study stopped it after 3 years because of the striking results. And then the study, after a 1-year bridge period, transitioned into an observational period, which is where we are right now. And so the lifestyle group intervention was actually greatly diluted, if you will. And also all groups were kind of given somewhat of a lifestyle intervention, but the metformin group persisted on an open label basis until actually 2021, okay? So what the graphic that I showed before, which I guess I could, well, I don't know where which I can actually show now, it's after 10 years, and actually you can see that there's a crossover of the glycemic. Here, what I showed in the graphic was glucose. So here, what you can see actually is that the purple is the lifestyle intervention. You can see that at the very beginning, the striking lowering in glycemia, but then over time, you can see that the metformin group actually crossed over and it was the most effective. And these results were significant. Now, I think there's two issues here. One is that the lifestyle intervention was a little bit washed out. I also think that conceptually, or at least heuristically, it is much easier to take a medication than to keep behavioral changes over time. I think that's the other thing.
That's that really crossover effect that jumped out at me, though, when I saw that.
Yeah.
And I was just wondering.
So in the long term, metformin was better. Now, there is a literature that suggests in animal models and in animal models and in human studies, and if you want to read more about this, I have a review article coming out in JHAD, Journal of Prevention of Alzheimer's Disease, which should be published very soon, which actually goes into all this literature in detail, okay? Both the beneficial and detrimental. Again, I would have to give a talk just on metformin in order to prevent that. But there were some animal studies suggesting that metformin increases amyloid levels, but there's as many studies showing the opposite, and then there's studies showing that it's neuroprotective. Anyhow, the studies are all over the place. And then there's some human studies, but they were mostly cross-sectional case control with horrible biases that suggested that metformin is related to a higher risk of dementia. And and again, in that review article, I think I described these studies in detail. But there's the best studies, epidemiologic studies that have been conducted that use methods to adjust for confounding by indication, which is a huge problem in pharmacoepi studies, show that there's an association of metformin use with lower dementia risk. So anyhow, one of the reasons, actually in my grants about metformin, one of the things that I point out is that we need to elucidate whether metformin is good or bad. And, which I think is actually one of the motivations that I have for conducting the study in the diabetes prevention program, which is in people with pre-diabetes and diabetes, and in the metformin trial, which is in people without diabetes. Actually, people cannot have diabetes because then the metformin effect could be confounded with other diabetes medications. So so thanks for pointing that out, and apologies for the omission, but yeah, I had to take out a bunch of slides from the presentation.
All right, so join me in giving Dr. Luchsinger a round of applause. Right before we close, I'd just like to say thanks everyone for joining us today, and please be on the lookout for our next professional development seminar on our series. Before I close, I'd like to see if Joe or George have any closing comments. Joe, do you have any?
Only to say that was a terrific talk, really, fascinating to see the whole range of what you've been doing and plus the things we talked about yesterday, which you didn't even mention today. So appreciate your visiting.
I just want to add, thank you so much, Jose, particularly for coming here. This is our first in-person RCMAR visiting scholar visit. So it's really exciting to have you here with us, and the fabulous talk, and we thank you for keeping it simple but not simpler.
Right.
Well, thanks everyone for having me here. Really appreciate it.
Thank you all. Enjoy the rest of the day and enjoy the weekend. Thank you.
Wonderful range of.
Yeah, really. It was, yeah.
I think
How you all-